Graphing parabolas using transformations. This is Harper's Ferry, West Virginia. This building in Harper's Ferry is known as John Brown's Fort. It was actually a fire station where, prior to the Civil War, John Brown and his men holed up and were captured after their raid on the armory at Harper's Ferry. Graphing parabolas. Like any other function, we can graph parabolas by making an xy table, choosing values for x, and using the equation to calculate values for y. If we recognize that an equation represents a parabola, we can often sketch the parabola more quickly by memorizing the shape of a simple basic parabola and making changes based on the equation. We will start with the most simple parabola, y equals x squared. We make an xy table. If we let x equal 0, we find y by substituting x into the equation. 0 squared is 0, so y is 0, and we put a dot at 0, 0. We try x equals 1. 1 squared is 1, so y is 1, and we put a dot at 1, 1. Next, we try x is 2. We put 2 into the equation. 2 squared is 4. So we have a dot at 2, 4. If we try x is 3, 3 squared is 9. So we'll put a dot at 3, 9. Now we try some negative values for x. If we put negative 1 into the equation, we want to square the negative 1, so when we square a negative number, the negative sign cancels, and we get y is 1. So here's a dot at negative 1, 1. When x is negative 2, negative 2 squared is positive 4, so we have a dot at negative 2, 4. If x is negative 3, negative 3 squared is 9. So we have a dot at negative 3, 9. Now connect the dots. And there's our parabola. Notice that the y values are squares. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So when we draw the graph, we go over 1, up 1, over 2, up 4, and over 3, up 9. Remember these numbers. They can be used to quickly sketch parabolas without using xy tables. Now we will try a variation of our basic equation. Y equals x squared minus 3. A number at the end causes a vertical shift. In this case, the graph is moved down 3. That is because if we were to make an xy table, before we figured out what y was, we would have to subtract 3 from x squared. We move the vertex down 3. So now we have a dot at 0, negative 3. We use the square numbers to draw some more points, starting with the vertex each time. First, starting at the vertex, we go over 1 and up 1. This gives us a dot at 1, -2. Because we're familiar with the shape of a parabola and know that in this case the parabola is symmetrical about the y-axis, we know there must be another dot straight across from the dot we just put in. And so we have a dot at -1, -2. Now, starting back at the vertex, we go over 2, up 4, which puts a dot at 2, 1. There will also be a dot straight across at -2, 1. To find our next dot, we start back at the vertex and go over 3, up 9. So we count over 1, 2, 3, and up 1, 2, 3, 4, 5, 6, 7, 8, 9, which gives us a dot at 3, 6. Also, there will be a dot straight across. Now we can connect the dots again to draw our parabola. Putting a negative sign in front flips the graph. Here our example is y equals -x squared plus 5. We start with the vertex, which has been shifted up 5 because of the plus 5 at the end. So we have a dot at 0, 5. Now, because of the negative sign in front, we know the parabola has been flipped. So instead of going over 1, up 1, we'll go over 1, down 1. So we use the square numbers to draw some more points, starting with the vertex each time. We go over 1, down 1, and draw our first dot. Our next dot will be straight across. Now, starting back at the vertex, go over 2, down 4. This gives us a dot at 2, 1. And there will be a dot straight across at -2, 1. Again, starting at the vertex, go over 3, down 9. And we count down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, which puts us at -4. So we have a dot at 3, -4, and we put another dot straight across. And here's our parabola, this time opening downward. Adding a constant to the x inside parentheses moves the graph to the left. Here we have y equals the quantity x plus 2 squared. Now notice that the plus 2 is not at the end, it is with the x in a set of parentheses. Changes to the x move the graph horizontally in the opposite direction that you might expect. So you might think adding would move to the right, but adding a number to the x moves it to the left. In this case, the vertex is moved left 2. So our vertex is at -2, 0. Otherwise, the parabola is the same shape as the ones we've just done. Starting at the vertex, we use the square numbers to draw a few more points. So we go over 1, up 1, over 2, up 4, over 3, up 9, and we draw the other points straight across the axis of symmetry, which in this case is x equals -2. Now we sketch our parabola. So we see we have the same shaped parabola, just shifted left 2. Putting a coefficient in front of the function causes a vertical stretch or shrink. Here our example is y equals 3x squared. This number makes the graph go up 3 times as fast. We haven't moved the vertex, so it's still going to be at the origin 0, 0. But instead of going over 1, up 1, we go over 1, up 3 times as far. That is over 1, up 3. And we put our dot. There's our parabola. We could put more dots in if we needed to, but we can see what our basic shape will be. Now let's combine what we've learned. This more complicated example is y equals -1/2 times the quantity x minus 3 squared minus 2. We see because we have -3 inside the parentheses that the graph has been moved right 3. And because we have a -2 at the end, the graph has been moved down 2. So our vertex, which starts at the origin, has been moved right 3 and down 2, so it will be at 3, -2. Because we have a negative sign in front, the parabola will open downward. And because we have the 1/2 in front, it will move down half as fast. So instead of going over 1, down 1, it goes over 1, down 1/2. Instead of going over 2, down 4, it goes over 2, down half as much, or down 2. Starting, of course, with the vertex. So we'll go over 2, down 2, and that puts a dot at 5, -4. The next dot is over 3, down 9/2, because it goes down half as far. And we can draw our parabola. So we see that in this case, we have a vertical shrink because it goes down half as fast, which in a parabola also looks like a horizontal stretch. It makes it look wider. But what we really did was shrink it vertically. If the equation is in standard form, you can use the same shortcut once you find the vertex. So if I have y equals x squared minus 4x plus 3, I look at that and recognize it as a parabola opening upward. I just need to know where the vertex is. The x squared term tells us that it is a parabola. And the fact that it's positive in front and has no coefficient except for an invisible 1 tells us that it opens upward and that there's no stretch or shrink. Standard form is y equals ax squared plus bx plus c. We find the vertex using this equation, x equals negative b over 2a. In this case, x equals negative 4 over 2 times 1, which gives us 4 divided by 2, or 2. We have the x coordinate for the vertex. We put the x value back into the original equation to get the y coordinate. So we have y equals 2 squared minus 4 times 2 plus 3, which would be 4 minus 8, which is negative 4, plus 3, or negative 1. So our vertex is at 2, negative 1. Now, as we've already said, there's no stretch or shrink, and it opens upward, so this is just our standard parabola. We could sketch in some more dots using our square numbers and connect the dots. The rules for transforming graphs work for any kind of graph, not just parabolas. On the next slide, we will summarize the transformation of graphs using function notation to represent any function. Function notation looks like this: y equals f of x. And remember, this does not mean f times x. F is the name of the function. So if we had y equals a times f of b times x plus c plus d, here's what all the letters would do. This number in front represents a vertical stretch or shrink, or a reflection about the x-axis. If the absolute value of a is greater than 1, it is a stretch. If this coefficient is inside the function, it represents a horizontal stretch or shrink, or a reflection about the y-axis. If the absolute value of b is greater than 1, then it is a shrink. A plus c on the inside makes it a horizontal shift. A positive value of c moves it to the left. And the number added to the end, in this case plus d, is a vertical shift. A positive d moves the graph up. Remember, horizontal changes happen in the opposite direction to what you might expect. So a larger number here, greater than 1, actually makes a shrink, and a positive number here moves the graph to the left. Now let's look at a non-parabola example. Y equals the absolute value of x. Remember, an absolute value graph makes this V. with a point at the origin. If I have y equals negative 1/2 absolute value of x minus 3 plus 4, I see that it has a vertical flip. It moves down half as fast. It moves down because it's been flipped over. It's been shifted right 3 and up 4. So the point is going to be right 1, 2, 3 and up 1, 2, 3, 4. So the point is going to be right there, and it's going to open downward. So we have the point at 3, 4, and there's our graph.